Hello, my name is Nishan Jha and I'm doing this reassessment video for my Physics 221 class. Today we're doing a work energy problem. It's a very simple looking problem, but it is very complex when it comes to solving it. The problem gives us a wagon wheel, a wagon weighing 90 kilonewtons moving at 18 kilometers per hour strikes a pair of buffer springs. If the stiffness of each spring is 600 kilonewtons per meter, determine the maximum compression of the spring before the wagon comes to rest. Okay, to solve this problem, first, since the wagon is hitting the spring, we need to find the kinetic energy of the wagon. To find the kinetic energy, we need to know the velocity of the wagon. Now the velocity of the wagon is 18 kilometers per hour. We need to change that to meter per second. So we multiply 18 by 1000 because 1 kilometer is 1000 meter, and then an hour is 3600 seconds. So we do that and then it comes out to be 5 meter per second. The kinetic energy of the wagon hence can be calculated by half mv square. So we plug in half and then times 90 times 1000 because it's a kilonewton, and then times the velocity square. The reason why we are dividing by 9.8 because we want the kinetic energy in Newton meter. So it comes out to be 114,679 Newton meter. Now this kinetic energy, this right here that we calculated, has to be observed by two springs to bring the wagon to rest. So now if x meters is the maximum compression of each spring, the maximum force exerted by each at full compression would be energy stored by each spring equals half times k times x squared. The k is the stiffness, which is already given to us right here, 600 kilonewton meter, and x is the distance traveled. Now we plug in the value. K is 600 kilonewton, that's why we multiply by 10 cube. And then since there is two spring, the total energy stored in the spring is 2 times this whole thing, which is 2 times half times 600 times 10 to the third x squared Newton meter, which will give us 600 times 10 third x squared Newton meter. Now we know the kinetic energy of the wagon is equal to the energy stored by spring. So the value that we calculated, 114,679, is equal to the total energy of the two springs. So we equal it out and hence we can find the x value. After that, the maximum compression force on each spring is given by Ks. K is the stiffness, and then S is the, what is S? S is the distance, or let's say the x. We plug in the values and then the maximum compression of each spring comes out to be 262.311 kilonewtons. Now this problem looked very easy, but a lot of things were going on in the problem. So if you guys did not get it, then you can drop me a comment below, ask me, or email me. I'll reply whenever I can. Thank you.